All right, hi folks, this is Larry Massolino. I'm recording a video for MATH022. I wanted to help you get started in Objective 2. And here are the topics for Objective 2. And you might not be working on all of these topics yourself because when you've taken the initial knowledge check at the very beginning of the course, you might demonstrate to Alex that you've already mastered some of these concepts. So Alex might be taking some of these topics off of your pie, but you might be working on some of the other topics. So let's do a few examples here. You'll notice in this Objective 2, the idea of working with fractions is discussed. So things like simplifying a fraction, multiplying fractions, reciprocals, adding, subtracting fractions. So let's do a bunch of examples. Let me come here to Introduction to Fractions just to get started. So they're trying to ask you here to write a fraction where the top of the fraction is the number that are white of these marbles, and the bottom of the fraction is the total number of marbles. So that's really what a fraction is. It shows the total number on the bottom and the number highlighted, I'll say, here on the top. So in this example, you could see there's 1, 2, 3, 4 white out of 10 total. So they're asking us to just write this fraction 4/10. Now, another topic is what's called simplifying a fraction. Let me actually go to the next topic here, simplifying a fraction. All right, so they want us to take a fraction and simplify it. What that means is write it as an equivalent fraction, but using the smallest numbers possible. And the way you do this is you look for some number that can evenly divide into both the top and the bottom. Top number is called the numerator and the bottom number is called the denominator. So we're looking for some number that can divide into both top and bottom. Well, you could probably see 7 would evenly divide top and bottom. So what you do is you divide the top number by 7. You have to do the same operation on the bottom. So I'm going to divide the bottom also by 7. On top, 21 divided by 7 is 3. On the bottom, 28 divided by 7 is 4. So this is the simplified fraction. Okay, and remember, folks, when you need a little extra help, be sure to come here to Alex and click on explanation. So if you'll notice here, this explanation will show you step by step how to find the greatest number that divides into both 21 and 28. We use 7, so they show you dividing the top and the bottom by 7. Okay, so use these explanations anytime you need some extra help. All right, let me go back. Let's come here to fraction multiplication. So if you go to the reference packet, let me go over to the reference packet. Remember, this reference packet is available. It's posted in Blackboard. I'm also going to email a copy to everyone so you can have a copy. Please print this out. This way you can have it handy for working on any of the knowledge checks. Any work you do in our course, you can use these reference sheets anytime you would like. Okay, and so if I scroll down a little bit, you're going to see that there are fractions discussed here. So here are properties of fractions. Then it's going to talk here about multiplying fractions, reciprocal of a fraction, dividing fractions. Well, let's do an example here, multiplying fractions. You can see here it says to multiply fractions, multiply the numerators and multiply the denominators. What that really means is multiply straight across on the top and multiply straight across on the bottom. So if I do that, I'm going to just multiply straight across. So that's going to be 5 times 7. Of course, that's 35. And then I'm going to multiply straight across on the bottom. 9 times 8 is 72. Okay, so multiplying is one of the easier operations with fractions because all you have to do is multiply straight across. We're going to see adding fractions is a bit more complicated, but multiplying fractions is just multiplying straight across on the top and on the bottom. All right, let's go do another example. How about if we do here reciprocal? Well, reciprocal means the reciprocal of a fraction really just means flip the fraction upside down. For example, if I gave you the fraction 3/4 and I ask you to find its reciprocal, I'm asking you to flip the fraction upside down and write it as 4/3. So in the first example, they're giving me the fraction 1/11. To get its reciprocal, I'm going to flip it upside down and make it 11/1. 11/1 is really the same as 11, so I can also write that as just 11. Let me go to the second part. It says, what's the reciprocal of 16? Well, what I'd like to do here is rewrite 16 as a fraction. So anytime I have a whole number, I can always take the whole number and put it over 1. So 16 is the same as 16/1. Now I'm going to get its reciprocal by flipping that upside down. So that's going to be 1/16. Okay, so reciprocal of a fraction means flip the fraction upside down. Let me go to the explanation here just to show you that the explanation is going to explain these two examples on finding reciprocals. Okay. Let's do some examples of adding or subtracting fractions. All right. Well, here's an example of adding or subtracting where you have the same denominator. So when you add or subtract fractions, you must have the same denominators. If you don't have the same denominator, you can't add or subtract. And you might say, what do you do if the denominators are not the same? Well, you've got to take some extra steps to get the denominators to be the same. We'll do an example like that in a few minutes. But here, the good news is the denominator is the same. It's 11 for both fractions. The rule is keep the denominator as is. So I'm just going to leave the denominator as 11, but I'm going to add or subtract the top numbers. Here it's a subtraction. 5 subtract 4 is just 1. So here's the answer, 1/11. All right, let's do another. Let's see, maybe we can do another. I'll do here, show another. Let's do an addition one. All right, well, again, here is an example where the denominators are the same. Keep the denominator as is. Add the top numbers. 4 + 1 is 5. So notice to add fractions, add or subtract fractions, you must have the same denominator. But to multiply or divide fractions, you do not need the same denominator. Okay. All right, again, this is on the reference packet. So if you forget these rules for adding or multiplying fractions, you can go back to that reference packet. All right, but what do you do if the fractions have different denominators? So let's take a look at this one. So this one is asking me to add together 1/3 plus 3/5. Well, I can't add these fractions yet because I need to have the same denominator before I can add them. So what I'm going to try to do is change these fractions and get them to have the same denominator. Well, the first thing I need to do is figure out what denominator should I be using. Well, we're trying to find what's called the least common denominator. That's the denominator we're going to be changing over to. The least common denominator is some number such that both 3 and 5 evenly divide into this least common denominator. So I'm looking for a number so that 3 evenly divides into it, but also 5 must evenly divide into it. Well, that number is 15, right? Because 15 is a number that both 3 and 5 evenly divide into. So I'm going to change each one of these fractions to have this denominator 15. All right, here's the way I'm going to change each fraction. What I'm going to do is multiply each fraction by some number over the same number. So these two red boxes have to be the same. All right, so what I do is I start to look at the denominator. I have a 3 here. 3 times what number gets me the 15 that I want? Well, it tells me I should put a 5 in this bottom red box. But once I put a 5 in that bottom red box, I must put the same 5 on top. Now I'm going to multiply across on the top. 1 times 5 is 5. All right, let me go to the second fraction. I'm going to do the same thing. I'm going to multiply by a number over itself. Again, these two red boxes must be the same number. Well, let me go to the bottom here. 5 times what number gets me a 15 that I'm targeting? Well, I'll put a 3 here because 5 times 3 is 15. But if I put a 3 in this bottom red box, I'm required to put the same 3 on top. Well, on top, 3 times 3 is 9. All right, well, now I can go ahead and add the fractions because now I do have the same denominator. The rule is keep the denominator as is. So I'm going to leave this 15. Add the numbers on top together. 5 plus 9 is 14. So that's the final answer. Okay, so there's a couple of steps here. Step 1 is find what's called the least common denominator. Sometimes you'll see this abbreviated as LCD. Then you have to change each fraction to have that same common denominator. Then you can go ahead and add. Okay. And again, if you wanted to, you can come here and click on this explanation to see some worked out examples. All right. Let me see here. Maybe we could do one more here. Let's go here. Solving a one-step word problem using the formula D equals RT. So there's a formula that's worth noting. It says D equals R times T. What it means is if you want to know the distance that you travel, let's say you're driving in your car, you take the rate or the speed and multiply it by the time. We abbreviate it, say D equals R times T. Let me give you an example. Let's say I'm driving 50 miles per hour and I'm driving for 4 hours. Well, if I'm driving 50 miles per hour for 4 hours, I'll multiply those together and I'll get 200 miles. All right, so let's use the formula for this example. So remember, it's going to be D equals R times T. All right, well, it says she drove 153.6 miles. Well, this is the distance, D. So they're giving me D as 153.6. What was her speed? That's the unknown quantity R. So R is unknown. 3 hours is the time. So T is 3. All right, well, it turns out, I'm going to write this equation like this. I'm going to put the 3 in front of the R like this. Well, we're going to talk about solving equations a little later in the course, but what you're trying to do when you're solving an equation like this is you want to get the letter R all by itself on one side of the equation. So I want to get this R all by itself. Well, for that to happen, I would have to get rid of or cancel out this multiplication by 3. Well, the way you cancel out a multiplication is you use the opposite operation. The opposite of multiplying is dividing. So I'm going to divide by 3 to get rid of that multiplication by 3. Well, usually the way we show it is we put the 3 below a fraction bar like this, because a fraction bar really means division. But there's a rule that says whatever operation you do to one side, you have to do the same operation to the other side. So I have to divide both sides by 3. Well, on the right-hand side, I'm multiplying by 3 and dividing by 3. But those are opposite operations, so they cancel each other out. So that's how I'm left with just R by itself on the right-hand side, which of course is what I want. And then on the left-hand side, I can just work this out. 153.6 divided by 3. If you work that out, that division is 51.2. So the answer here is 51.2. This would be miles per hour. So we use the formula D equals R times T. D is distance, R is the rate or the speed, T is the time. All right, folks, hope this helps you get started in Objective 2 in ALEKS.